Okay. Hello, everybody. Welcome to wasmCloud Wednesday for Wednesday, January 22nd for the community meeting. I'm going to share super briefly and then share because the first item on our agenda is actually not a demo, but even more exciting. I wanted to welcome a couple of our new wasmCloud maintainers. So this is all let me see if I can find, yeah, the most official version of this. This is all taking place under this team in GitHub. And we have a little bit of a spiel in the Wasm Cloud Slack, but I wanted to give a warm welcome and thank you to Zhou or Mossaka, Mark, who's here on the call and can wave at you, OSS fellow on GitHub, but Masoud, who is here all the time giving us such awesome feedback. Luke Ark, who is a huge member of the Wasm Cloud community. I don't know if he's actually been on this call, but he's essentially built an entire platform on Wasm Cloud and just consistently pushes Wasm Cloud to its full limit. And will, is always willing to do is pretty much always willing to submit fixes and help us out. Aditya, who is here on the call, who's always in the community calls, always taking on essentially, I don't actually remember when Aditya joined and started looking at Wasm Cloud, but essentially started with like good first issues and has now contributed like an entire implementation of a wRPC interface and the providers, and which is awesome. To roll back up because I forgot I was giving a whole spiel. Masoud gives such wonderful feedback in the road mapping sessions, in the community sessions, really keeps us at a high bar in the community for, staying true to what we promise to do. And, we say that we wanted to work on something or expand providers, and is always helping us do that as well, especially with Nat's key value, Nat's blob store. Mark, beyond just being here and being able to wave at people, thank you for you've submitted PRs for so many different things across Wasm Cloud. It's kind of hard to keep track, but you're over on wadm helping us get rid of some old things. You're over in Wasm Cloud doing everything from like examples to PRs, which is awesome. You were bored. Get bored more often. We'll take it. And then Joe, who is not here on the call, goes by Mossaka. If you're involved in the WASM standards or the WASI cloud effort, or you've been to a conference for anything related to WebAssembly, you've seen him around doing talks, and he's actually contributed a fully featured Azure Blob Store provider to Wasm Cloud. And he expressed a good bit of interest in being more involved in the community, and based on the expertise in the Wasm side, we're super happy to have him join. So thank you everybody. We kind of went through a round of maintainer nominations a week or two ago. Thank you all for accepting. But you all have probably already seen these people interacting with you in the community, and you will continue to see them interacting there. So really happy to expand the Wasm Cloud team with some more maintainers. Um, I've left some time in the call. Mark, Masood, Aditya, would any of you like to give your acceptance speeches now, or did you want to do that later? You got my message to set up like 30, 45 minutes of speech, right?
I'm prepared. I talk to a lot of people and I'm always ready to go.
Well, in all seriousness, if you guys want to say anything, then you're welcome to. But uh, thank you and welcome. Um, okay, all right. Well, why don't we go ahead and get started with the regular agenda then? Let's take a look on the. I'll share my whole screen because everybody gets to see the fun stuff. Well, the We got a couple of demos and discussions today, and then one final discussion to kind of go over the wasmCloud roadmap, which we planned during the community meeting last week. The first demo and discussion, as promised, as I was maybe unreasonably passionate about during the road mapping session, is embedding wadm and wasmCloud into Wash. This one did make it onto our roadmap with a promise to essentially spike on it. So let me see if I can open this. This feature, Roman actually filed quite a long time ago. Thank you, Roman, who's not here. Suggested, hey, we have a Rust binary in Wash. The Wasm Cloud host is basically just a lightweight binary around the Wasm Cloud host library. Why don't we just embed the Wasm Cloud host crate into Wash? And we had totally valid discussion, and I'm not just saying that because Taylor is here, like totally valid reasons around like why this not might not be a good idea, taking a look at some things. I don't know anything about the maintainers of this project, so I'm sorry, but like I know that Hypercube was one thing that like included all the Kubernetes CLIs and it was big. And like that's not what we want Wash to be. So what I did really want to do for this spike is to show what this looked like. Like what would it actually be like if we embedded wadm and wasmCloud into Wash? So the main difference, I don't know where my diagram went, but the main difference here is essentially when we are, and we'll start with code, but then actually get into a little bit of a demo. When we are setting up a process like wash dev, where this is supposed to be like an ephemeral environment, we stand up the local Wasm Cloud platform, load your component and any capabilities that it has. You can do your hot reloading, and then when you're done, we want to close it all down. So what we do right now is, I created this flag called fully embedded. It's just kind of temporary naming pending. Is we will download Nats, wadm, and wasmCloud from their GitHub releases. So just like the latest version, we embed the version in Wash so it's kind of stable, and then we'll actually execute those binaries. So this is what happens when you run wash up. We'll start the binaries, and then when you control C that out, we will actually stop those binaries. If you turn on this flag, we're now going to call a couple of functions here in this little embedded module. This is full POC because I just wanted to bring up a couple things and do this spike. Start nats, start wadm, and start host. And what these different functions do, the Nats one's a little special, so I'm going to skip it for now, is we start the Nats server, and this actually just calls a function to start it, and then it attaches to this process. So when you kill the wash process, the Nats server goes away. We start wadm, and this is actually using latest PR, the latest version of wadm that allows you to call this function start wadm, and this actually just does the same thing that the wadm binary does. And essentially do the same thing for starting a host. We create a host configuration. Because this is for development use, we turn on like file loading and the experimental features, and then we run a host and we return, here we return the public key, but you could do more fancy handling of it here. So basically, just like wadm and wasmCloud are like thin binary wrappers around their own libraries, now we've just brought those libraries into Wash. So when we run, oh no, I didn't compile ahead of time. I'm so sorry. Uh, if we run, uh, okay, it's not going to be too bad. If we run wash CLI locally, maybe with a local component, and we enable the embedded flag, then this will kind of go through this code path that I've shown you. While we wait for that to actually compile, thank you, Rust. Let me talk about the Nats embedding piece. This is actually one of the more complicated bits of this feature. Nats is actually a Go binary and library. So if you're writing a binary in Go, you can do what we've done with wadm and wasmCloud. You can bring in whatever the Go word is, that library, and run Nats inside of your own program. With Rust, it's a little bit different. But what we have actually a little experimental library for is embedding the Nats server dynamic library and linking that at, you can dynamically link it or statically link the actual Go binary to wash. So the FFI here is really simple. There is an unsafe here because it's an FFI call. But the Go binary is actually an example of embedding NAT server. So we take in a couple of flags and command line options, and then here is the line of code that actually starts the NAT server. The special bit here is here. So the FFI module expects for us to have a dynamically linked library that has this NATS start NATS function, which is implemented in Go here. Now, what we basically have to do, and this only sort of works in, like I said, experiment, is when we build the Rust library, we need to be able to find this shared object file, the dynamic library, and then say that we're going to link that dynamically. Now, for actually distributing this, we'll need to statically link this because we're not going to expect people to build this library. Awesome. I actually already had NATS running. So let me run this again. So we run the dev process. You can see that we actually start the NAT server just like starting the NATS binary. And then we are running wadm and wasmCloud after that. It looks like it sort of kind of worked. Let me see if I can do. I did not do an app list. Maybe wadm didn't start. Maybe not. Ah, come on. Oh, that's probably why. Looks like I had some streams left over. One more time. No. Okay. Well, fine. Um, I'll figure out what this is. I'm gonna try one more thing. Uh, I didn't fully test all the edge cases for this, of course, but you know, that's how it goes. I think it might be getting a little tripped up with a stream that I was using. Let me try this one more time. Darn. Running into some state. One more time for real, for real. So the essentially what happens here is we start Nats, we should be able to start wadm, we should be able to start wasmCloud. And all of the processes are actually included in this one running wash process. So if I do a PS and I look for Nats, wasmCloud, wadm, wash, where you would previously see three, you can see that we actually just have that one process where I'm running wash from like cargo run. So this kind of combines everything into a single binary, which is great. Um, the uh, the other piece of this, which is actually a new feature in wadm, is actually Mark. I think you did this one. Is being able to change the stream persistence for the wadm streams and key value buckets to in memory. So the a big aspect of this is that once we actually close down this dev session, all of the streams and key value buckets from the dev session will just be deleted. And this actually eliminates a whole host of frustrating things around, links being left over from a previous installation. If you end up killing Nats first before wadm, it ends up cleaning up configuration and development manifests, things that are meant to be kind of ephemeral and not kept for a long time. They kind of get cleaned up automatically. It keeps cleaning up wash really easy because it's just a single process. And I figure I would show just the one last aspect of this, not to mention the fact that we didn't actually need to go download any binaries to make this happen, so this will work offline better. The actual size of the size difference of the release binary. Currently, if I build a Linux, do I have Linux on here? Yeah. Currently, if I build a Linux binary for Wash, which is statically linked, like for the muscle target, um, that comes out at 21 megabytes. So you have the statically linked binary, and then under Wash downloads, wadm is another 22 megabytes, NATS is 14 megabytes, and the 1.4.2 and wasmCloud is 34. So like in total, you end up downloading quite a bit. The difference here is the statically linked binary for Wash that includes the wadm and wasmCloud libraries is 31 megabytes. So the actual Wash binary increases, by 10 megs, but you don't need to download wadm or wasmCloud. And it will increase a little bit more than that because we need to statically link the NAT server binary, or sorry, dynamic library. But that shared object is about 15 megs. So the wash binary size looks like it will about double to around 45 megabytes. I'd like to make sure that this is consistent for all of the targets. However, it really didn't end up blowing up too much to make this work. We can fully preserve the functionality to be able to download the binaries too, like if you wanted to test with different versions. But my conclusion from this, other than the demo, other than this being a POC and the demo not going all the way through, is that I think the binary size did not grow enough to be concerned about it. And I'd like to revisit this with a more focused lens on, well, error handling and the whole process. But I'd like to proceed with this work. I think this would be a great enhancement to like the dev process experience. Okay. I talked about a lot of things, pros and cons. Yeah, Taylor.
One thing that I know will be of interest, because the other debate that was going on in that thread was around the fact that this doesn't necessarily represent what someone would be doing for real, in like whereas you could at least make the argument the other one is. And there's also arguments for wanting to be able to use those things for different stuff, whether you have like a local NAT server you want to test with and all those different things that we've used Wash Up for. And I know this is totally, I'm the audience plant question here. How would you think that stuff is going to be handled, for people who still want to be able to download the things or download specific things, but not other things and all that jazz?
Yeah, that's a good question. For for Wash Dev, I have less of a I I think it's less likely that someone would want to run their own Wasm Cloud or Wadum or even Nats um standalone for that. Only because I mean the only scenario I would think you would want to do that is if you were like connecting in your dev process to like a different lattice, which feels like a whole lot. I think we could support that. I think that more likely somebody may want to use wash up in the detached mode to run like a local Wasm Cloud platform with Nats and Wadum and Wasm Cloud and then just kind of, forget about it, which it isn't how we recommend running things in production, but you could totally do it like on a Raspberry Pi. That's what I do. So I think that that would still be useful to be able to manage Nats and Wadum and Wasm Cloud separately. But I think for dev, honestly, the embedded mode is a reasonable default.
Yeah, my thought on the work here is that like this should be the default, and then we, I think, have the conversations as a community. I'm curious what other people, not that we have to have this discussion now, I'm just so for people to think about as we do this, like what do other people who are using Wasm Cloud use Wash Up for? Because if it really is always just for dev or something, then I don't feel like keeping around the ability to download stuff really adds much. But if it's something where it's like, oh, I use this to spin up like an ad hoc thing that connects into a lattice for debugging, which I will admit I have done, like maybe we keep those kind of things around. So I think I'm excited that this turned out so good. Um,
Yeah, just got to make sure I know how to statically link first. Yeah, and no sense in throwing away good code. So totally willing to keep the up for stuff for a little while. Cool. Well, maybe please feel free if folks have any other comments, let me know. But I can not sure when exactly I'll get this feature done, but when it's a little bit more feature complete and maybe we can get like a draft PR up for it. Be nice to do like a full build, see what the different binary targets like size differences, make sure that like, you know, it's not a thing that like on x86 Mac, it's like 200 megabytes or whatever. But yeah, I don't know why it would be that. So yeah, great. Thanks folks for watching the demo. We'll be able to talk about this one a little bit more too. Um, Taylor, I know you have a demo, but before you go, sorry, Joe, I'm going to put you a little bit on the spot here, but we did do a shout out to the new maintainers a little earlier in the call. So welcome and thank you so much for getting involved and coming to the call and everything. I actually don't know if you have been on the community call or maybe not in a while. Okay.
I think this is the first time being here.
Wow. So we do normally ask people if they want to do like an intro. Would you like to do a quick intro about like what you do and all that stuff?
Yeah, of course. Hey, everyone. My name's Joe. I'm a dev at Microsoft, and I work on a lot of WebAssembly upstream and WebAssembly plus OCI plus Kubernetes stuff. And yeah, and I'm pretty interested in a lot of the WASI proposals like WASI key value and WASI blob store, and all of them are under the same umbrella called wasmCloud. And I think that's part of the contribution I made to the wasmCloud that uh, made me a maintainer of this project. I'm super proud to be that.
Yeah, thank you, Joe. And thanks for doing an intro, especially kind of on the spot. I appreciate it. Um, but yeah, totally more to come from WASI Cloud, from everything WebAssembly. Speaking of other people who've worked on WASI Cloud, Taylor, I think it may be time for your demo. Seamless transition.
yes, totally seamless because my demo has nothing to do with that today. But anyway, yes, I do work on wasmCloud with Joe. Joe and I have fun over there. I'm going to go ahead and demo a new chart we landed in there in the main repo, I should say. So let me go ahead and share. This is going to be a ye old terminal demo, but we always try to keep it exciting. So let me go over there and share it. So what we've noticed is that people really want the ability to do like benchmarking of their different things. We're going to also be using this to release like standard benchmarks for wasmCloud here relatively soon, which Lucas demoed about a month ago. So I'm going to go ahead and actually show this up. I'm just pulling up this so I have the command right. So if you, I'm sorry, I'm grabbing the link. That's what I meant to say. Let me grab. So we have a new benchmarking chart, and this is targeted at people who are running inside of Kubernetes, though technically it could be used to benchmark something outside of Kubernetes and you just be using Kubernetes for the load testing. That is also perfectly acceptable. But let me get the link here and send it through chat. This new chart is now available, and I'm going to demo it right now. So that the thing I linked has all the instructions on it. But what we have is that we're able to now. So I have just my normal cluster. So you can see that I have my NATs and wasmCloud cluster and stuff running through the Kubernetes operator we have. And I'm going to go ahead and do this with Helm. So I can install a benchmark here. I'm calling it my benchmark, and I'm installing it from OCI. So this is now available from OCI. You can see it right here, and you can pull it down and install it because Helm has support for that. And then everything just require the only thing that's required is setting a test URL, which is the URL you want to hit to actually get the thing going. So I'm going to go ahead and do this. It'll take just a second while it downloads and gets things going. But I'll come over here and show you as things spin up. I did the wait flag, so they'd all be done. But it's going to spin up basically a whole Grafana, Loki, tempo stack, just all the stuff that just a simple stack that's isolated from the rest of your stuff. So even if you already have Grafana, Tempo, and Loki, the whole point is this is self-contained purely for this test. So this will go ahead and spin all those things up. It'll initialize all the things, get stuff going, yada yada, all the stuff you'd expect Helm to do. And while we wait for the paint to dry on that, I'm going to go ahead and so I'll keep that over there so we can all see it. But let me go ahead and share a different screen real quick. 1 second. Oh no, good, it finished. I'll stop there and then I'll show the other stuff in a second. So when it's done, it prints out what you can do to get the logs and also what you can do to see the graphs, which I'm going to have to share my browser anyway in a second. So what I'm going to go ahead and do is port forward with that command it gave me. And then I'm going to share a new screen. Now that we have that. That's the one. Okay, sure. So this is the chart thing. It has all the documentation. I'll go back there in a second, but I'm going to go ahead and go to localhost 3000, and you'll see that it pops it up, and there's standard dashboards for the cluster that it installs in there. But the big one is the one that we include called test environment. And you can see that the test just started. So if you've never used K6 before, K6 is a load testing tool that is released under the Grafana project. It's very, very useful. There is a K6 operator, which is what this chart installs. And that lets you distribute out a whole bunch of load onto various servers or node pools, whatever thing you want to put it on to generate the load for the servers. And so what this does is it runs about a 1 minute long test, and it's using OTel to capture this data. That's why there's a bit of a lag. It sent out the event as soon as it started the test, and then the test actually kicked up, and you can see where it finished and came down. So this was doing, I think, a 5,000 requests per second load test. This is just running on my machine, so don't, like on just a little like orb stack thing. So don't trust any numbers here. But like the whole point is that I can come in here and watch this rotate through like basically in real time and see what's going on with the test. So you're able to run a benchmark. And I'll show you another thing in just a second what that looks like to configure that. But I'm able to keep like run all these tests, and then I can, do the normal Grafana thing and spin it out, and then I can come here and look at the memory and CPU usage for each of the pods in any of the namespaces I select. So I have those all right here. But it allows you to come through here and then see your pod usage over time. That's obviously less valuable to you if you're targeting something outside of your cluster, but it'll give you all the latency things, P99, P95, P50, and then any failure rates, which there shouldn't be right here, but then it gives you the success rates over time. So this basically captures all that for you, gives it a nice graph. This is all technically in the Prometheus that's installed too. One of the things I'm working on next is a script for our testing, for the wasmCloud testing stuff, to be able to fetch the data from Prometheus and tell us like what kind of like rates it got to, and then other data like that. So that is basically it for those things. The one thing to know about is there are multiple ways you can configure this. You can pass in tolerations and selectors, so you can like target it to specific pools you're using for load testing. It also supports passing through basically the exact same format that you'd expect for a K6 test scenario. If you haven't seen this before, this won't be familiar, but if you have done K6 tests before, this should look pretty familiar. You're able to basically pass through any number of scenarios you'd like to be able to like say like I'm going to do it at X rate or like whatever rate you want to do through here, and you can add multiple scenarios that will run one after the other or at the same time, however you want to configure it. And then those things will show up on the graph as well when you're running them. So all of these things are completely configurable, and you can pass through with the values. So that is the benchmarking chart. Any questions?
Since it is using OTel, if I had to look up, let's say, traces for what was happening inside the test, where would I go to?
I think we have those hooked up in Tempo here. for parts of them for anything that's coming from the K6 test. If you want to look at traces for wasmCloud itself, that like we can't assume how you've set up your OTel. So we have full OTel support for wasmCloud. So you would look wherever your wasmCloud OTel stuff is set to export to. That would be the where you get it there. So that's where you're going to get that OTel data on those things. This is getting the OTel data from K6 and like tempo and traces. So anything that is sent out via K6 will come into here, but anything else will go into whatever you have configured for your normal wasmCloud lattice.
Gotcha. Thanks.
Yeah.
So Taylor, you may have said this a little bit earlier, but this chart, is it like wasmCloud and the test? Like this is just like showing a full example? Like, can I use this with my existing, like I already have wasmCloud deployed in Kubernetes or something, and like I've got a couple like HTTP and messaging services or whatever. Like can I hook this into my cluster like locally or whatever?
Yes, and that's what it's designed to do. This is meant to be put in running things, and it has to have a service somewhere that it can hit. So you have to have a service that's either been generated by the operator that you've created that's pointing at. Right now, this just supports HTTP. We can also make it support messaging. We have a NATS one. But really, like, I just wanted to focus on HTTP first because it's the most common and gives people just kind of a basis of their cluster performance. Now, this is just going to be for wasmCloud itself, and it'll allow you to test the different things. It can you can test it using the built-in HTTP server or like the HTTP server provider, or you can test it like with something else that's doing your own setup. However, you have all that it needs and all that it cares about is an HTTP endpoint to hit. Technically speaking, you could even use this chart to test something that isn't wasmCloud related. But it's really meant to be like showing really just around like the wasmCloud side, like pointing at the whatever URL you have internal to your cluster or external to your cluster, and then returning the results.
This may be a dumb question. Feel like using this locally, pretty easy, do the benchmark. Is there anything that people should watch out for if like deploying this to dev or QA? I mean, I'll say prod, which you may just say no, but like, like a long running Kubernetes cluster, like hard to clean up or any like concerns there?
No, honestly, it's meant to be deployed, and when you're done with it, you can delete the Helm release entirely. It's not meant like that's why I said it because it is spinning up additional resources in your cluster. Um, the thing that's in there is installing the K6 operator, so you'll need to be able to install CRDs. But really, like you don't want to we don't want to have to support like manually glued together K6 stuff for those who don't do that. So if you can't support CRDs, you can't use this right now. But you can also take some of the same principles and use them if you'd like. And we can continue adding knobs and dials and things as people use this. It does work in, like I was running this locally, but I also ran this like in an AKS cluster. And, it's the same thing either way, just because you're relying on just the fact that there are containers there that can run. So, the core competency of Kubernetes. So, like I said when I was showing the extra instructions, there is an example values in the chart link that I sent that shows like, okay, I'm going to schedule this on another node pool, so you're not like clobbering things. And that's generally what we'd recommend when you're testing in staging or testing environments, even or prod or something like that. What you'd want to do is keep that stuff that's running, especially the tests. The other things are very low overhead, all things considered, but the tests themselves can start to really take up a bunch of memory because they're, slamming CPU more than memory, I guess, really because they're slamming things. So what you're going to want to do in that case is make sure you've spun up a separate node pool and you're targeting that node pool.
Sounds good. Folks have any other questions for Taylor on the benchmark and Helm chart? Alrighty. Um, this is the time in the community meeting when I hijack it for a demo again because I was doing one thing wrong, and don't mind me. But it does actually work. So take a look at this. The thing I was not doing was awaiting a future. So thanks, Rust. So let me this demo. We started WashDev, it's everything we talked about before. You can see like I'm dumping all the output for nats and nats to the foreground or whatever, just so you can see it. But what this is doing, this ran through my wash dev process, and you can see that it actually restored the streams for wasmCloud on config and lattice data, which is important. But the main thing to note is that it is not restoring wadm streams. So if I do a wash app list, I can see, this is my current development session. I can curl localhost. I can get like my component that's running. As soon as I control C this process out, I can start it back up again. If I do another wash app list, you can see that my previous version of the application is gone. And this is what we do for wash dev now too, but we actually do it during the teardown process. We delete the application and then hope that everything is okay. But if I wanted to, maybe simulate a more drastic failure, then I just like killed wash, right? Like we didn't have any time to do any cleanup. I bring this dev session or the next dev session back up, take a look at the app list, and the old one is still deleted. And that's because the wadm manifest bucket was created. What was that? Like, I don't have seconds over here. A couple seconds ago. And this is just because we're getting rid of it after each dev session. So this was the only other thing that I wanted to show and show that I wasn't just showing smoke and mirrors. It really did work. I just forgot to do a thing when I refactored a little bit. So yay. Okay. Other than that, we only have one more thing on our agenda today, which is to just I saw something in the chat. Oh yeah, thanks. Thanks, Joyce. Which is just to point out the wasmCloud roadmap page has been updated. So if you go, from the wasmCloud homepage and everything to docs and then to roadmap, this is actually the full kind of overview of the Q1 roadmap, which we planned last week. It does link over to it does a little bit of try to give a little retrospective on what the Q4 roadmap of last year focused on, which we really made big improvements on the Golang side, performance improvements, auto-generated docs, and really refocusing on wash dev. Obviously, we're continuing with a lot of those things, and just a little bit of a spiel on what we want to do for the first quarter. So putting it more into higher level goals than specific issues. So a lot of this quarter is going to be focused around stabilization, rigor, capability providers, our SDKs, development of WASM standards and WASI P3, and integrating those into wasmCloud as soon as we can. And then other high-level goals that we keep as core tenets of the project consistently around enabling developers to build these components, WebAssembly components without vendor lock-in, platform-specific dependencies, all those things. You all have already drank the Kool-Aid, so I don't need to convince you all here. What's present on every roadmap is the top list of features that we want to offer. This actually, I don't think, hasn't changed since the beginning. It's good to just remind ourselves every once in a while. And the diagram, which I should probably rename, we have kind of moved to doing all of our planning in GitHub projects. So here we are. The first item has already been completed. Thank you, Taylor, for taking a look at the Helm chart for benchmarking wasmCloud applications. So, woohoo! I figure I can go ahead and update my ticket here to say that bundling wasmCloud in Wash is something that's kind of in progress, but not generally too much momentum on the roadmap yet. But we already did one. If we can just do one item a week, I don't know if we have enough weeks for that, but we'll be close at least. So great. So if folks have any other questions or comments on the roadmap or anything, please feel free to let me know. Just a note that we do have a little bit of automation around this roadmap, but it's not like I have to come in here and move things around all the time. If we complete a issue, then it gets moved to completed. So yay. Great. Yeah, Masoud, go ahead.
A question about that draft issue about using the provider SDK as a testing framework. You know, at least when I checked it, it didn't have any details. So can you elaborate what is the intent there, please?
Yeah, of course. So we talked about this one during the road mapping session, if I remember right. So we didn't have a full description or issue behind it. Part of it is exploration. I think we know that the current process of writing integration tests for wasmCloud providers leaves a lot to be desired. And I wrote provider SDK here. It may be more accurate to say the wasmCloud test util instead. But the first thing that I'd like to do for this ticket before I turn it into a full issue is kind of go through the Nats Blob Store provider PR, that set of integration tests that you wrote up, Masoud. And um, I mean, unfortunately, I don't know what like the issue is there, but we've noted a couple things in this little like draft note that there may be issues with running like multiple concurrent tests. But holistically, I'd like to make the experience better. But I understand that for an issue, we probably need to make that a little more concrete.
So I want to provide a clarification. I think I said something that could have been misleading. So the integration test for the Nats Blob Store provider, that one is using the test containers. It's not using the wasmCloud testing framework.
Okay, so you're just using test containers, not
I'm
the test
using
util.
I'm using test containers. The issue seems to be around wRPC calls within within that, you know, harness or whatever you want to call it. It you know, I have checked and triple checked. Well, actually, I spent quite a bit of time trying to resolve the issue. So that it was the issue really is around making wRPC calls.
Okay. That is really good context. I might have misinterpreted that in the last call then. I think then quite honestly this issue, and I guess I don't need to talk into the void, this issue though, revisiting provider testing probably needs to just be approached a little bit more broadly. I think what it's gonna take is us on the maintainer side, or someone who's written quite a few providers. I know there's a lot of overlap there. You know, a lot of the maintainers or a lot of the providers that exist today are written by wasmCloud maintainers, to revisit that process and start filing issues for things that aren't working properly. For wRPC, like, and the test containers, you know, let's see what the issue is there. That one could be related to the way that we use wRPC, in which case maybe the test util crate should provide some helpers, or you know, upstream documentation we can contribute to like give better best practices, like how to use wRPC to test. That's something we could totally contribute. And then when it comes to integration tests for providers, um, I I think we really feel the pain when we actually get back to writing tests here. I know a couple of us on the call, like Jonas, I think you did a little exploration last year around some provider tests. Um, and yeah, little more to improve there. I think the test util gives really nice primitives for like launching a host, launching the test containers for like Nats and maybe wadm as well. But I don't know if it prescribes well enough, like the kind of tests that you can write with it. So I think if we don't get a little bit more information on this one onto the roadmap, then I may move the draft issue off or convert it into like something that's separate and we can bring on like individual issues to fix since it's just a little broad. All right. Other feedback or questions on the roadmap?
I have one more question. It's not necessarily roadmap, even though it's part of the roadmap. For the PR that is going to go out this weekend for SBOM and those for provenance, because really the target is only wasmCloud workflows. My question is that when we're modifying workflows, how do we test it without putting something out?
I mean, that's just a wider issue in the industry with GitHub Actions in general. With those kind of tests, there is Act, which gets you part of the way, right? But like, but I mean, GitHub knows this is an issue. I just don't think they've resourced solving this side of things. It is very difficult to test. It's my
I
least
do
favorite thing
have
about
I do
writing them.
have ACT. I do have ACT. The reason that I was inquiring was that maybe we have something in-house or something, some way to test workflows before pushing them out.
Yeah, I mean, right now that's just a wider. See, here's Taylor's opinion, which of course it's getting captured for all posterity on the internet. But the thing is that CI still is one of those things where it is pick your least worst poison for your situation, and so there's not really a good answer here. I've always said that the first like company or startup that can come up with a or find some way to like unify this and make this like really good for anything is going to be a very popular company. But there's lots of companies out there that are doing that and they have their own advantages, but they also come with a lot of their own disadvantages too. So I don't know that we can solve that. um, the thing that I try to do is um, we've tried this with a couple things, like, and none of them I've really loved. Like, we have some stuff in make files, so you run the make target, and if you're running that locally, it's roughly the same. We have the Nix stuff, but you have to know Nix, and that's hermetic, which introduces other problems. And so, like, there's different solutions and things we can try here. But and this is also just an open invitation. If anyone's passionate about this and they're like, I want to get involved in wasmCloud, and you have a passion around this, I I think nobody would complain if you came up with some really cool ideas to do it, but it's just part of, I guess, the ecosystem. So yeah, like, and the chat is the chat is backing me up here. So I think that like yeah, like, and that's the thing. Act is like one of those tools, like it's literally a community provided thing, and so the fact that it works is always amazing, but also like we do some pretty crazy stuff in our pipelines. So it's not like it's just like, oh, use this standard tool that builds this project and then like push the artifact to the release. We do some of that, but there's other things we're doing too, and we're only adding more. Like, I'm adding benchmark testing, which involves using a kube config to spin up a whole bunch of, and then like some cloud config stuff to spin up some nodes and so on and so forth. Like, that's all going to be in there. And so the short story of that long rant is that like I don't think it's something that is entirely within our control, though we have been, as we were talking about a couple weeks ago, been trying to improve our own pipelines so they're at least faster. than they were.
So yeah, Masoud, as you get started on it, let us know if we can help you with anything like, you know, part of the workflow is making sure that they can run on your fork properly. If you wanted to test a workflow I won't put implementation details into what you're doing, but publish an SBOM for a component or what have you. So, you know, whatever you end up working on is what's going to come into the wasmCloud core. So we definitely want to collaborate on it.
Sure.
All right, folks. Well, we've got a couple minutes left. Didn't run crazily over like last week. Do folks have anything that they wanted to bring up for discussion? Talk about in the broader WebAssembly ecosystem or in the wasmCloud world?
I'm just going to say this out loud because if I saw the comment come in on the right stream of things, I think someone named Jake on LinkedIn who was watching the dev call said they were working on some fun stuff on the Nix side of things. If you are, please let us know in the Slack channel or somewhere so we can let you demo it inside of this call because that'd be awesome. So I'm just going to call that out here because it's easier than trying to respond out to the comment in whichever social media platform it is coming from.
Look at that. Streaming on LinkedIn. It's good for something. All right, folks. Then I think
I
that.
just remembered one thing. I have to stand in for Liam. Remember, everybody, Cloud Native Rejects closes on Sunday. So if you have those rejections, especially if they're WASM related or any of them really, from KubeCon, please submit to that. Rejects is always fun. I actually my secret confession is that I often like the rejects tracks more than some of the tracks at KubeCon because there's so many interesting and crazy things that obviously make sense why they weren't like selected for KubeCon, but are really interesting talks. So submit to that if you got rejected from the other ones, or even if you didn't and you just want to submit a talk. Rejects is a real fun and very chill conference.
All right. I think that is it for real, for real. Well, thank you everybody for coming to wasmCloud Wednesday. We will talk to you a little bit later. See you a little bit later in January for the last wasmCloud Wednesday of January. And I think that's it.